Welcome to this topic on engine controls for the Airbus A320 family. We're going to go ahead and look at some of the components and the locations of the components related to the engine control system. There's the objective here, just become familiar with where they're located, etc. And then also, of course, there's test questions regarding the material. The test questions, as far as the number of them, is not going to be as extensive. And we're also going to have a piece by our commercial airline pilot on staff. Rick Poe will be presenting a little piece, a little bit more from a pilot's perspective as far as engine controls. Alright, so let's go ahead and get started. Just in general, this is going to be a very short piece. You're going to be understanding what comprises the engine controls. And part of that is so we have like a subtopic. It's a subtopic of throttle control and understanding a little bit more of the mechanism there. Again, there's not much to this, but be aware of what happens when, if you do this, how is that going to affect something? What's the consequence of doing that action? For example, switching on the switches as far as the starting the aircraft. Okay, so let's go ahead and get with this. The engine control system is made up of a throttle control system, or throttle control. You also have engine master switches. These are going to be for, obviously both engines. And then you also have your fuel control. And that pretty much does it as far as the broad stroke of your engine control system. Now, be aware on the throttle control levers, there are two of them. And just so you know where they're located, we are talking about the center pedestal, where all of that is located. Up above on the overhead panel, there will be a display of light, for example, when it comes to the fire fault light. That will all be indicated on the center pedestal, but it'll also be located, or there'll be an indication on the overhead panel on 115 VU. So don't let that confuse you. It's not one or the other. You have it in both locations. Okay, the master switches, of course, when we talk about starting the aircraft, we're switching on the switches for engine master 1 and 2, and 1 or 2. And of course we have the FADEC that's involved with being able to send signals, etc., to activate the different mechanisms. The throttle control system that we have, like I said, is two thrust control levers, and when the aircraft is turned on, they don't automatically move. Because some aircraft have it so when you're in automatic, and by the way, there's automatic and manual start, and in your automatic mode, those thrust levers do not move on their own. That's a test question, by the way. So just, kind of keep that in your notes about that. The switches, when you have the engine master switches, control switches on, they are interfaced with a couple of components. One of them is going to be your fuel shutoff. Obviously, when you start the aircraft, there has to be now the instruction or command to get fuel to the engines. So with that automatic position, when engine master control switches are on and you're not in manual start, you're going to have the shutoff valves start to open. I'm talking about the low pressure shutoff valves. So to keep in mind, I'm going to share with you right now that we can compare because you're going to see this on the test, is when you're in an automatic mode, the low pressure shutoff valve is going to open. You have your low pressure and high pressure fuel shutoff valves. When you're in automatic, the only valve that opens as far as your fuel goes is your low pressure one. If you're in manual start, that's different. In manual start, both the low pressure and the high pressure shutoff valves are opened. Okay, so you see what the comparison is between those two modes. You know now what that is. Okay, so again, make sure you make a note of that. Of course, once you start the engines, with the master control switches, the first thing, or say first thing, but one of the things is going to happen besides opening up the fuel shutoff valve, in particular we're talking about automatic, it's going to be your low pressure shutoff fuel valve, is going to be your start valve. Okay, so the start valve is going to open as well, besides the fuel shutoff valve. Okay. And of course you're going to start to see displays on the ECAM. Okay. All right, and of course we also have the fire push buttons. Fire is always a concern when you're dealing with a flammable fluid like fuel. So once you have that activation of the fuel shutoff valves being open, now you've got a fuel flow going. And there's always that potential if there's some electrical fault somewhere, you know, there's a potential for obviously a fire. So we do have the engine fire push buttons for engine 1 and 2. And just know that that's part of, you know, part of that whole engine control. All right. And there's, you know, the diagram here kind of gives you an idea of, you know, where they're positioned as far as the master control switches in relation to your fire fault lights, and also your mode selector. The mode selector, just to give you an overview, you've got 3 different modes. We'll go into a little bit more detail in a bit, but just want to give you a broad stroke or helicopter's view on this. You have 3 different positions. Your normal is going to be dead center, okay, as far as the mode selector button or knob. And you have also the other positions of ignition start and your crank or dry cranking. Okay, so those are your 3. And like I mentioned before, let's talk a little bit about throttle control. Throttle control is done with the thrust levers. You do have 2. And you also have on these thrust levers the selections of auto thrust or manual thrust. Okay, so those are on there. And I know that we're not talking about a DC-9, so, you know, we're not talking so much mechanical links, etc., and mechanical connections between your thrust control levers to the engines, which, you know, you'll have mechanical links, etc., that in some of the older models like the DC-9, etc., but you don't have this in Airbus. There's no mechanical connection between the engines and the thrust control levers, just so you know that. Everything's pretty much electronically measured as far as, you know, how much input to give, you know, to have that thrust for the engines. Okay. The other thing too, if you notice on the diagram in front of you, again, this is just a helicopter's view giving you that broad stroke, but as you have the center pedestal, that's the main place. And then below that center pedestal, you have the artificial fuel unit. This is for the throttle control. So that's where that's located. So if you ever, or, you know, asked on a test, or even asked in an interview, you know, where's the thrust control artificial fuel unit, that is located below the center pedestal. Okay. All right, and there's different positions. Do be aware, you don't have to know so much of the degrees. I can certainly go into that, but it's really not that important. What you want to be aware of is there are 6 detents or positions on that thrust control handle. So they obviously have for full throttle, for reverse throttle, so you've got a negative, right? You got a 0, which is your neutral, and then you have your negative 20 degrees downward, so that's reverse throttle. And you've got up to your 45-degree TLA, okay, your thrust level angle. Again, don't have to be memorizing 45 degree or negative 20. Just be aware that you've got 6 detents or positions in which the thrust can be placed into. Okay. Also, the FADEC, which controls, you know, basically gives instruction. Your FADEC, again, just to reiterate, is your full authority digital electronic control unit. It's always here preventing the engine from exceeding RPM limits. And if you're, there's some of you are interested in a little bit more detail about the physics between your RPMs, engine RPM, and also your EGT, because exhaust gas temperature limits are extremely important to a pilot. Those are one of the things that are looked on the display, you know, being able to make sure that it's within the green, making sure within limits. Very interesting relationship between, obviously, those 2 aspects or parameters when you're flying the aircraft. Okay, and just kind of give you some terminology regarding your thrust control levers and positions, like the names of them. You have your CL, which is your climb, that's your max climb detent, and that would be roughly about, I would say, 25 degrees, roughly. It is at 25 degrees. Don't memorize the degrees. Just know one of the detents is your climb. The other one's your max continuous or flex for flexible, by the way. Flex takeoff, you'll see that detent with the label as FLX MCT, okay, for maximum continuous thrust, and that's at 35 degrees. Okay, so max climb is one of them, just so you have the knowledge, and another one is your max continuous flex takeoff. Okay, with the reduced takeoff or flex, which is what I just mentioned, they can be selected there on the ground with a flex temperature, okay, FLEX temperature, that's entered on the MICDO. And again, I kind of want to have Rick just explain a little bit more of that to you, since operationally he's in the cockpit and can explain and get into more of information that you may not be privy to because you're not a pilot. But understanding it from his point of view, which is a representation of every pilot who flies a commercial aircraft, will be able to, again, enlighten your position as you're working on these aircraft. Okay. You also have idle stop. Your idle thrust, it can be selected with one of the detents. That's kind of an intermediate mechanical stop. So that's another position. Remember I said about reverse, I mentioned negative 20 degrees TLA, which, okay, your thrust level angle. That's reverse. So that's your reverse idle. You have idle stop, reverse idle, you got your CL, which is your climb, and then I mentioned about your flex, maximum continuous thrust, which is abbreviated as FLX-MCT. Okay, and just kind of a note, when you have the plane in a reverse position, on landing, the ground spoilers are going to be deployed. So, I mean, that kind of makes sense, but I'm just verbalizing it so you have it in your head. And of course you have reverse full. Okay, so let's come in at the full aft reverse detent. And again, the FADEC is there to protect the engines. And therefore, when you're putting something in a full position, the FADEC gets involved to ensure that it's not, the engine's not exceeding those RPM limits. Okay, all right. I do want to talk a little bit about the artificial feel unit for the throttle control, since we're on throttle. This is like I mean, if you've worked on or opened up, been able to see some of the quadrants that are underneath the control quadrants, this is no different. You've got links that are mechanical, so it's basically there to connect it to the engine. And again, from a pilot standpoint, rather have Rick kind of explain what happens there. But the artificial fill unit's there as a friction system and giving that load feedback, to the pilot as he's controlling the thrust control levers. So that's what that's there for. And it's artificial fill. There's computer systems for that, etc. But there is that mechanical control quadrant that exists. And again, just know that that is below, obviously below the center pedestal, below the whole engine control area. Okay, artificial fill control, the artificial fill unit has different assemblies. You got obviously gear and level, and your friction brake assembly that makes up that. Okay, and basically what it's doing is just taking mechanical energy, right? Taking all of that and transforming it to a rotary movement at the bell crank. It's just mechanics that's connected to the engine. Alright. Alright, so let's go a little bit into the power control. Throttle and thrust, by the way, are interchangeable. So if you see it in a manual or somewhere, throttle is thrust. It's thrust control. When we talk about power, or we say, maybe engine control, it's an input. Okay, so for example, let's just kind of go a little bit. I'm going to talk, when I talk about engine master control, I'm going to go over some details there, and then I'll cover a little bit on the fuel control. With the engine master control, remember, engine control incorporates comprises the throttle control, your fuel, your fuel control. Your engine master control we're talking about primary controls. That's going to be your switches, because nothing's going to happen until you hit a switch. So there's engine master control switches for engines 1 and 2. And then you also have an engine mode selector. You know, are you doing the selecting engine start? You know, what's happening when you select that? If you do that, what happens next? Versus if you are have it in a norm position or dry crank. Okay, and also you have your fire fault light for each engine. That's part of those primary controls. Okay, remember all of this is located on the center pedestal. Now the switches, when those switches are on, I mentioned it's about how it opens up the low pressure control valve if it's in an automatic mode. So it is controlling those fuel valves. And it's going to start that engine starting process, right? Which start has to do with what? We got another valve that I mentioned earlier as your start valve. Okay, so we got a start valve. I'm going to take a little moment at this time to switch over, because I do want to make sure I don't forget to mention some of these practice questions, because chances are you're going to see this on the test. So let's go ahead and let me throw out a question for you. All right, this is a true and false. By the way, the test has multiple choice mostly, but there are true and false questions as well. Okay, number 1, the FADEC does not prevent the engine from exceeding RPM limits. Is that true or false? That's false, because remember I said that it does prevent the engine from exceeding RPM limits. Okay, where are the thrust levers located? Is it the center pedestal or the overhead panel? Okay, it's the center pedestal. Where's the throttle lever artificial fuel unit located? Is it left of the captain's seat or below the cockpit where the center pedestal is? Okay, it's the second choice. All right, where are the master engine control switches located? Is it the center pedestal or the 110 VU panel? Okay, I was talking about I just mentioned before, right? Center pedestal, that's where those controls are. The thrust levers move on their own after the engine master control switches are switched to the on position. Is that true or false? That's false. Remember I said they don't move. In some aircraft they do, but not here. Okay, the eng mode, eng mode, E-N-G-M-O-D. Okay, the eng mode selection is used for what 3 different positions? I literally just mentioned that. Okay, here are your 2 options. Number 1, ignition start, comma. Okay, your second is, wet start and normal mode. That's one option. Or number 2, is it normal mode, dry cranking, and ignition start? You're right, it's the last option. Okay, normal mode, dry cranking, I mentioned dry crank, and ignition start. Okay, so that gives you an idea. We're going to come back to our test questions in just a bit. But let's see what happens here. Now, let's suppose, remember I said the 3 mode selections, you have dry crank or ignition start in your normal mode. Let's just pretend that you're putting it in ignition start. Okay, when you do the mode selector and move the knob to ignition start, what happens? What is it affecting when you do that? Okay, when you're doing that, you're going to obviously have a display engine page. Okay, that's automatically going to be displayed. And what's going to happen is it's going to open up the start valve, right? That's one thing. So you have the start valve that's going to open up. You also have your low pressure fuel shutoff valve that's going to open. And you're going to have indications, okay, on the FADEC, or excuse me, on the ECAM. All right. Now, just remember I mentioned about the FADEC, it's going to be commanding things. That is connected obviously to the electrical system, and that automatic start is going to start with the control switch on the on position. So it's all connected so that FADEC can control things. Okay. Also, just be aware, kind of a side note, you have pack valves, and the pack valves, if you have an engine master switch on, even if you're on manual start, if you do the push button for manual start, by the way, if you push the manual start, both low pressure and high pressure fuel shutoff valves open. Remember? Or I said that. So yeah, just remember that, manual start. So let's just say that you have the master switch, the engine master switch, or manual start push button is not selected. Let's just say it's not in the on. Within 30 seconds, then the pack valves are going to automatically open. Okay, and why is that? Why are they going to automatically open if we don't have a selection of on, quote unquote? Well, it's doing that to prevent unnecessary pack valve cycles. Okay, so it's just all these protective mechanisms within the programming. Okay. All right. So that's a little on the ignition start selection. Start valves are going to open, and then your fuel shut-off valves. Now, what about dry cranking, or the crank mode selection? Because it's just CRA and K. So if you're selecting that, let's say you have it in that position, you have that, and what it's doing, it's allowing the engine to be dry cranked. Okay, so dry crank means what? Dry means not with fluid. So when you're selecting that, it's on the ground. It's not opening up the fuel shut-off valves. So you don't have fuel flow in that position. Does that make sense? Dry crank? Okay. So that's what's happening there. And then just a little added thing with automatic engine start versus manual engine start. I'm going to say it again, but I remember I told you what shut-off valves on the fuel side open or not open, right? On manual engine start, the ignition's initiated using both igniters. Okay, that's just a noted aspect to manual engine start. On automatic engine start, you have an indication on the ECAM on your engine warning display, in particular, of the N2. Okay, and I'd like to do like a piece. I'd like to do a piece on N1 versus N2. Speeds and how it relates to your EGT, etc. And anyway, Rick and I are going to do a piece on that so you can understand a little bit more about that, just kind of more the relationship with all those aspects. Because it is fascinating, and it just helps you just get an understanding of the dangers that can be there if things are not, working properly. Because EGT is extremely important with making sure they're within limits. That certainly can get become a problem when you have the temperature too high with that exhaust gas. Okay. All right, and then your fuel shut-off valve. Okay, I mentioned that before. That's just, obviously controlling the fuel, or allowing the fuel to flow. The fire push button, is there. Okay, so remember I mentioned normal mode, your dry crank, your ignition start. Those are your 3 mode selectors. And then the fire light that's going to come on if, there's an engine fire detected, then that light's going to come on. Remember that I said there's on the center pedestal, you're going to have an indication of the fire fault light, but then you're also going to have it on the overhead panel on your 115 VU. Okay. All right. There's really not too much to know. Just I hope this gives you a familiarity with the engine master control switches, and then what 2 different positions we have with that, and that's going to be automatic in your manual, and what happens when it's an automatic versus manual start is what valves are going to be affected as far as which ones are going to be opened. And then your thrust levers, there are 2, also on the center pedestal. And with the thrust levers associated with that, you have your throttle, or your throttle artificial fuel unit. Okay, as well as a throttle control unit. Okay, so it pretty much gives you an idea there. Again, Rick's going to talk about, well, kind of just enhance this subtopic with a little piece just to speak kind of more conversationally to both to all aircraft maintenance technicians regarding the engine controls. Okay, if you have any questions about any of this, certainly email us and we'll be happy to get an answer for you. We look forward to having you in the other lessons.